So here is another question on linear inequations in one variable. So it is given, solve the following inequation. 2y minus 3 is lesser than y plus 1 is lesser than or equal to 4y plus 7. It is a different kind of inequation. It's a very interesting one. It is a very good question. So pay attention to it. And there are two conditions. In the first condition, the first bit, we have y belonging to this set of integers z. So that is the replacement set. And in the second case, y belongs to r, the set of real numbers. So we will solve it. So first let us write down the inequation in one variable. Here the variable is y. So don't get confused. So far we have come across questions where x is the variable. Here y is the variable. So the inequation is 2y minus 3 lesser than y plus 1 lesser than or equal to 4y plus 7. So here the given inequation, it consists of two parts. The first part is 2y minus 3 is lesser than y plus 1, and the second part is y plus 1 is lesser than or equal to 4y plus 7. So we have to solve them individually. So for the first part, here we'll take this plus y, which is on the RHS side, to the LHS side, it will become minus, and this minus 3 to the RHS side, it will become plus. So that implies 2y minus y is lesser than 1 plus 3. That implies y is lesser than 4. So this is the first part of the solution. Then the second part, here we'll take this 4y to the LHS side, it will become y minus 4y is lesser than or equal to this 1 to the RHS side will become minus 7 minus 1. That implies minus 3y is lesser than or equal to 6. So here, if you remember one of the rules that we have studied, that if both sides of the inequation, if we change the sign, plus to minus, minus to plus, whatever it is, if we change the sign, reverse the sign, the inequality gets reversed. So here, if we change minus 3y to plus 3y, that is simply 3y, and 6 to minus 6, then this inequality lesser than or equal to will become greater than or equal to. Okay. Now we'll divide both sides by the same positive number. In that case, the inequality will stay the same. So 3y by 3 minus 6 by 3, that implies y is greater than or equal to minus 2. So this is the second part of the solution. So here we have two conditions, y greater than or equal to minus 2, or we can write it as minus 2 is lesser than or equal to y, and y is lesser than 4. So this is the solution. Now we have to pick only those values from each of the following replacement sets which satisfy this condition. So for the first condition, where y is the replacement set is the set of integers, the solution set will be minus 2 lesser than, y should be greater than or equal to minus 2, and it should be lesser than 4. So the solution set for first bit will be minus 2 minus 1 0 1 2 3. Okay, because it is y is lesser than 4 and greater than or equal to minus 2. Okay, and for the second bit we have to write it in this format. The solution set for the second bit is y, this condition minus 2 lesser than or equal to y lesser than 4 and y belongs to a set of real numbers. This is the format in which you write the solution set. Okay, so this is a very good question, okay, because here we dealt with an inequation which consisted of two parts. So we solved individually each part, then we figured out a combined solution, and then we determined the solution sets. Okay, so this is the. So here is another question on linear inequations in one variable. So it is given, solve the following linear inequation given by 2x minus 7 is lesser than 4 with x belonging to the replacement set 1, 2, 3, 4, 5, 6, 7, and we have to plot the solution on the number line. So it's very simple. The only difference is that here we have to plot it on the number line. Okay, so the inequation 2x minus 7 is lesser than 4. Now we'll take this minus 7 to the RHS, it will become plus, that implies 2x is lesser than 4 plus 7, which is equal to 11. Now we'll divide both sides of the inequation by the same positive number, 2x by 2, 11 by 2, so this becomes x is lesser than 11 by 2, or we can write it as x is lesser than 5.5. Okay, so this is the solution of the given linear inequation. Now here in the replacement set there are no decimal numbers or fractional numbers, so it's all natural numbers, distinct natural numbers up to 7, starting from 1 to 7. So here we have to pick the solution which fits the criteria for the given solution. So it is lesser than 5.5, so we can start from 1 and go up to 5. So this fits the criteria. So the solution set for the given inequation is 1, 2, 3, 4, 5. This. Now if we have to plot it on the number line, so we'll draw first the number line. Let's say we start from 0, okay, 0, 1, 2, 3, 4, 5, 6, okay, this much. So now all those distinct natural numbers which are there in the replacement set which fit into the criteria of the solution, which is lesser than 5.5, from the solution set, we will highlight them with darkened circles. So 1, 2, 3, 4, 5. Okay, this. Okay, so this is the solution on the number line. Okay, so here 5.5 is not there in the as per the solution set. 5.5 is not there in the replacement set, so we will not be highlighting that. So it's somewhere here, okay, in the middle. 5.5, so it's not there, so we will not do the hollow circle thing because it is lesser than that, but it is not present in the replacement set, so we will not do that. So this is the solution on the number line. So here is another question on linear inequation in one variable. So it is given, solve the following linear inequation. 4 minus 3x is greater than or equal to 3x minus 14 with x belonging to the natural numbers, the replacement set, and we have to plot the solution on the number line. So first let us solve the inequation. 4 minus 3x is greater than or equal to 3x minus 14. So here what we'll do, we'll take this minus 14 and bring it to the LHS, it will become plus, and we'll take this minus 3x and take it to the RHS and it will also become plus. So we have 4 plus 14 is greater than or equal to, the sign of inequality will stay the same, no change, 3x plus 3x, that implies 18 is greater than or equal to 6x, or it's the same as 6x is lesser than or equal to 18. Now we'll divide both sides by the same positive number which will not affect the inequality sign. So by 6 by 6. So we have x is lesser than or equal to 3. Okay. So this is the solution of the given inequation. Now the replacement set is the set of natural numbers starting from 1, 2, 3, 4, 5 and so on, like that. So from this we have to pick the solution set which satisfies this condition, x lesser than or equal to 3. So if you see these three values 1, 2, 3, they satisfy the criteria. So the solution set is 1, 2, 3. Okay, this is the solution set. Now for plotting it on the number line, we'll first draw the number line. Okay, then let's say this is 0, this is 1, this is 2, this is 3, this is 4 and so on. So the solutions 1, 2, 3. So darken, solids filled in circles 1, 2, 3 to highlight the points. So this is the solution on the number line. Okay, so this is the thing.